Right, well, apart from we've got a York 863 to put together, as you all know, and a DNT to try and finish fault finding for the 10th time, and apart from a Rotel 240, which we've not even shown yet with the phase lock loop problem, we're going to move on to this Danita 440, which I've never seen before in my life, and it is a CPT only FM radio. It's approved for the UK, otherwise we wouldn't be looking at it. CP PR27GB, and it is CE approved anyway, because it says so on the blurb I've got here from the from Danita's website. So, make a start on this. 31st Jan 25, Danita 440. Seal number 3041142. So being CE approved, I'm expecting it to have a half decent receiver. I'm not going to just power it up. We'll have a look inside. I'll tell you what, we'll test it. We will test it. Right, I need the mic. Did anyone see where I put the mic? It's got a scan, I noticed. That could be useful for some people. The customer's also sent a TTI and I brought the wrong mic. Okay, so now we've got the correct Danita mic with the 5-pin DIN plug. Right, we need to reset all the test gear to go to CPT band. So 27205. And to be nice if it was a straightforward retuning test. The customer thinks it will be, and that would be great. Right, well, we can hear the signal generator at, well, that's 100 microvolts, and it's reading so many thingies. What happens if we put the signal up? You get more thingies. So we've got S9. There's no thingy to say where you are. We've got 1, 2, 3, 4, 5, 6. It's lighting up 6, whatever that means. Right, we'll start by going into PA, and it says PA in the window, which is nice. Testing 1 2, testing 1 2, testing 1 2, 1 2 1 2, but it doesn't do anything. Testing 1 2. Try again. Testing 1 2, testing 1 2, 1 2 1 2. So it's quite possible we've got a sticky, which is now clean. That's now working. So the mic works, we know the speaker works, and we know PA works. We know the sockets work. Right, let's go into transmit. So I'll put picture in picture on, and we'll select program camera. Which is that one. So on the 3 watt scale, let's have a look. It's doing more than 3 watts. It's doing 3.2 watts. Right, let's change channel. It's not an up-down mic, so we've got to use the up-downs on the radio. Channel 1 is 3.1 watts, and channel 40 is 3 watts. Doesn't have low power, it's not a 2781 set. Go back to channel 20, and it's 845 milliamps. Deviation, I have to retune the thing because we're on a different band to usual. 1212, wallow. It's showing 2.8 on this test set, and we'll verify it with the one behind me. Frequency, gear's been on for ages, so let's have a look at camera 2. 2720492 is virtually spot on. Should be 205 of course. Right, so let's see where we are with the sensitivity. To be honest, it sounds off frequency, but it isn't, unless it's got a separate... Oh, we're off frequency on the signal generator. I was going to say it could have a separate transmit and receive arrangement, but I doubt it. Okay, we're now on frequency, as you can see. So we'll go over to the cyanide meter, which the mice keep moving. And for 12 dB, this will be crystal filtered, I expect. It's 0.42 microvolts. For 10 dB, it's 0.35 microvolts. If it does 20 dB, it does 0.88. Squelch seems a bit vicious, so let's turn the squelch to full and see where it is on the signal generator. Let's put the attenuator up on the screen. Right, 1, 3, 10, 30, 100, and up we go. It does come in, and it comes in at 3 millivolts. So much higher than I would have it, but as long as it's got the sensitivity at the bottom end, set the radio to threshold and signal generator back on, parked at 0.3 of a microvolt. Nothing. No, that isn't good enough. It's 3 microvolts. It needs to be really less than 1.4, otherwise it's going to cut up around scratchy corner. When we press transmit, how many lights do I get? I get 8. 8 lights. I don't know what that means. Perhaps the instruction book will say so. So we've gone through that, and the set works. Oh, it's in German, this. Okay, I could have printed less pages out. Oh no, it's got English as well. So what does monitor do? It's got this monitor position. In monitor mode, the incoming signal can be heard in the PA speaker, and when the PTT switch on the microphone is activated, the transceiver operates as if in PA. So it's like you monitor the CB through the PA speaker, but you can't transmit on it. Right, okay. Oh, it's the wrong side. Would you believe that? So we've got a subboard here. I'm going to switch the set off. We're going to take the subboard out. I need to know what it is. Well, something with a 4558 looks to me like a speech processor, but I could be wrong. Anyway, it doesn't interfere with any presets underneath. It's slightly obscures what I expect to be deviation. So VR4's under there. So if we see what some of these presets are. VR1, VR2, VR3, VR4, we know there's 4. So, have we got anything in line with the squelch one, is the first question. And the answer is not that I can see. That makes the squelch non-adjustable, doesn't it? I can't read this well enough. I may have to see whether I can read it on the computer screen better. So that's clearly going to the bar graph. That looks to me like VR1 is received, but I could be misreading that. So we're going to have frequency here. It uses Sanyo LC7185 synthesizer. Got an untouched VCO, so that's not going to be messed with. Transmitter is going to be up here. Output is there. Front end looks to be here. And IF and detector down there. So let's see whether we can get a little bit more power out of it. I don't think it's going to be variable power. Let's just have another look at the squirky. Can't see anything. So it doesn't look like we've got a squelch preset. That's sad. So we've got one that's going to be deviation. Got one there which is either, it's probably going to be squelch, but it's in the vicinity of that part of the circuitry. And then we've got another 3. You know, you'd think transmit meter, receive meter and squelch, but I can't see squelch, so. Right, anyway. That's the squelch on the front panel as far as I can tell. There's no preset going to it. Right. Switch on. Go back to the first meter. See whether we can get a little bit more on transmit. So as ever, it's the peak of the centre. So that was correct. Just managed to trim that a fraction. That was correct. They're going to be receive. I think that's going to be transmit meter. It is. So VR what? 6. So that's a good start. We've not gone beyond 3.2 watts though. I think final alignment is with these coils. .4. Right, what we're going to do, connect it to the deviation meter behind me. I think that's deviation. Absolutely spot on, but I need to prove which is deviation. It's peaking at 2.5. Well, that isn't deviation, so in that case that's squelch, but I can't see squelch on the circuit. How bonkers is that? Wow, it's not that. Wow, it's that one. Oh, good, well. So we've got VR5 is deviation. And this one down here, VR4, is squelch. So I don't know what VR3 is. We'll come to that. It's in the receiver. Oh, but I bet it's the receive meter. I'll better just plug back into the other test set. So 100 microvolts. Let's see whether that affects it. It does. Good. So the VR3 is receive meter. So we've got transmit meter, receive meter, deviation, squelch. What on earth's that up there then? Let's go back to transmit. Well, that does affect transmit power, and we're just a fraction from 4 watts. .8. VR7 is TX power. Good. So we're going to have a quick look at receive. We'll jot these figures down in a moment. Very quick look at receive. I'm supposed to be doing something else right now. VR3. Turn the volume up a fraction. And find the detector, which is going to be, I think, that one. That was spot on. I think we'll do the IF first and drop the squelch, so I can do it. About 12 dB on the cyanide meter. So, see where we were before, it was 0.42. So just see whether we can get a little bit of improvement on the IF. Possibly on that one. I'm satisfied that is really good. So now we'll just do the front end. Gained a bit there. That's fine. I think we've gained a fraction there. Might just have gained something there. But the proof of the pudding and all that, see what we've now got. The 12 dB. Oh yes. We've now got 0.35. It's going to get another 20 yards range, this. 0.3. And for 20 microvolts, 0.72. So let's see whether we can do the squelch a bit better. So put the squelch to full. Let's put the attenuators up on the screen. And see whether we can get that squelch to be open at 100 microvolts. We can. So that's exactly where I want it to be. Now let's see where we are on the sensitivity, because this is so important on an FM system. So we've got threshold on the radio. So we'll switch the signal generator back on. No, it's not that good, is it? Let's try again. Signal generator off. squelch absolutely on the threshold. In fact, we've got it at 1.15. Let's put that 1.2 down. So it's a bit of a finicky one, but you can do it. So we've got 100 microvolts. We've now got 1.2 microvolts on the squelch minimum. Well, at least it'll go around scratchy corner. So we'll just put 100 microvolts on the radio, and that is all but 2 how I've set it. So the receive meter was variable resistor 2, wherever it's gone. Oh, it's 3. It's that one. So you can see we can adjust that. That would be plus 30, I suppose. That's 9. So that's where it was. I think we'll have it like that. So if we add a bigger signal, we'll get plus 30, which we weren't getting before. Then it goes down correspondingly. So we've got that about as calibrated 8 lights. So it was 2.5. And so it's exactly the same at reset. Just pop it on frequency. It's there. It hardly needs touching. There we go. We'll come back and read the power when I get back. Right, so back onto this, and we'll just do the powers, and that wraps it up. So it's nice to have a relatively straightforward retune and test, even if I've never seen the set before. So let's see where we are with power. We're on channel 20. There's our 5 watts on the meter. Right, 3.6. Oh, I don't know what it is on 20. .6 still. Right, 3.6 on 20. .5 on 40. And on channel 1, 3.7. So there we are. That's somewhat more balanced. Remember, we're on a selective power meter. It's going to read a lot more than this on a normal power meter. But this is what the government inspects. I'm not saying this particular model, but they would be using something which is selective if they were inspecting. It's now 947 milliamps. Anyway, we've gone up 0.4 of a watt, haven't we, or half a watt up there. So that's good news. So switches and potentiometers work fine. Is it crystal filtered? I think they're supposed to be. Or is it before the rules came in? If this is CE approved, it's supposed to be crystal filtered. It isn't, so is this an early version? It doesn't say it's CE approved on the back, but it does say it's UK approved on the front, so there we go. That's, it's approved, and that's all we're bothered about. I wonder who makes this for them then. Any clues on here? No clues. Good, we're done. We'll put this together and we will do an on-the-air test. Not the right screw, that's out of the rotel. This customer's also sent in an intake, but we'll do one or two other sets first. So to recap, brought the frequency up a bit. It was virtually spot on. We brought the power up a bit. We've got a little bit more out of the receiver. So all in all, there's some effect, but it certainly was a working set as it came in. I've no doubt somebody will look in their back stash of magazines and say how much money these were in 1985 or 1987 or whenever they were out. It's going to be somewhere around that era. Thinking of CPT sets, I haven't seen a SATCOM CPT set for years. You know, we used to get them coming in for repair from time to time. The CPT SATCOMs, because they were the last of the Cybernets, and then Cybernet got bought up by Kyocera and ended up as a solar panel factory. So all that radio expertise lost, gone. Right, we'll pop it on the aerial. There won't be anybody there. Perhaps there'll be some interference. Turn the test gear off. Go to its own speaker. Oh yeah, the thing on this was squelch, wasn't it? It was awful. It's not the most sensitive squelch in the world now, but oh, it's got scan, hasn't it? Let's see if that works. So how does that work then? Do you have to hold it? Let's turn squelch to full. Just scans. Does it scan once? Tell you what, we'll take the aerial out so we can actually see how this thing works. So it does scan continuously. We'll put the aerial back in, and once it sees a signal, then it stays. Yeah, right. I think it's the Midland 98's got scanning. It scans once, it's useless. Is it 14 for a copy on CP? 1 for a copy, 1 for a Roger, I mean. 1 down a Roger. Now we have it, the Danita 440, a radio I've never seen before, from around 1983-1985 era. We're doing on the air test, so it's CPT FM only. Thanks for watching.